Hey Pre-Calc gang, we're continuing on with Chapter 4 today. Today 4.3, the remainder and factor theorems. These are pretty crucial in this chapter, so hopefully you'll be able to hang in there and do alright with this. I think some of the things you've done before, but a little bit different twist on them makes it a little tricky. First of all, this thing called the remainder theorem. So here's your main polynomial. Notice we're dividing by just a binomial, and that binomial has to have just a single power of x, or whatever that variable is. So that's one of the restrictions here. Anyway, the remainder is simply when I take the original polynomial and put this r value in place of it, which is kind of cool. That if all you're looking for is a remainder, you don't need to do any big long division. You can just substitute in what you're dividing by in place of that polynomial. Let's take a look at an example of that right here. Hopefully you can read this green thing here. So I have x cubed minus 2x squared plus 5x minus 3. I'm going to divide it by x minus 3. If all I want to know is the remainder, all I have to do is put 3 in place of this x. So I'll do that. So I have 3 to the third minus 2 times 3 squared plus 5 times 3 minus 3. So I think I can kind of do this in my head. This will be 27. I have to make sure to do my squaring first. So that's 9. 2 times 9 is 18 plus 15 minus 3. So 27 minus 18 is 9 plus 15 minus 3. I have to work left to right here. 9 plus 15 is 24 minus 3. So it looks like my remainder, which is all I was really concerned about in this case, will just be 21. That's the remainder theorem. Here's something you might have done before, probably in advanced algebra, something called synthetic division. So we'll take a look at what this looks like. It's a shortcut way for dividing a polynomial by a binomial. And notice once again that binomial divide by has to be just x minus r. So you can't be dividing by x squared or x cubed or anything like that. So here's my example, as you can see. Now I always like to start out and put the thing you're dividing by kind of out in a box off to the side here. And notice in this case it's actually a 2. And if it would have been x plus 2 I was dividing by, I would have put negative 2 in there. Then I simply write the coefficients down. So the coefficients are the numbers that are in front of the variables. So for x squared it's just a 1. For negative x, I have to think of that as negative 1, and then I do put that constant in there, which is a 4. And then I draw a line like this. I bring this first number straight down here like that, and then I go to town. So all I always do is multiply the number in the box by the number down here, and I put my result right here. So in this case, it's going to be 2 times 1. I'll put my result right there. So 2 times 1 is 2, and now I just add. Negative 1 plus 2 is 1, like that. And then I keep going through that whole same process once again. So 2 times 1 is 2, 4 plus 2 is 6, and then I'm actually done. So my quotient here in this case will simply be the coefficients of what I have left, but I have to remember to reduce my power by 1. So I have x squared, I'm dividing by x to the first. My final answer then will be just an x to the first. So my answer will be 1x, and then this plus 1 like that. That's my quotient. And the 6 that's left over, that of course is called the remainder. So my quotient is x plus 1 with the remainder of 6. Again, I could have found, if all I was looking for was the remainder, I could have found that much more quickly simply by plugging 2 in place of x in that original thing. But I was more interested in the quotient and the remainder in a problem like this. Next we're going on to something called the factor theorem. This is really crucial that you understand this. A lot of times we're looking for factors of these polynomials. So I'm trying to find the remainder when I do this. So I'm going to go back to my remainder theorem. Well, actually, let's try another synthetic division. We'll try doing it that way because we maybe need a little bit more practice than that. Once again, I look at this. I see it's x minus 3, so I'm going to put plain old 3 in that box over there. Then I'm just going to write down all the coefficients. So I have a 1, a negative 1, a negative 5, and a negative 4. I draw my arrow straight down, my arrow here, my line here, and I bring that 1 straight down, and here we go. So 3 times 1 is 3. I write that here. Negative 1 plus 3 is 2. Again, I always multiply this by my result down here. So 3 times 2 is 6. Negative 5 times 6 is 1, like that. And 3 times 1 is 3. And negative 4 plus 3 is negative 1. Now all I'm really interested in is the remainder here, and so my remainder is what is left over right there. And because my remainder is negative 1, I'm going to say that x minus 3 is not a factor. If it was a factor, the remainder would have been 0, and it would have been able to divide in there evenly. So that's what I was looking for there in just trying to find the remainder. So x minus r, in this case x minus 3, is not a factor of this polynomial because there is a remainder. Last example here, we're trying to figure out the binomial factors of this thing. And unfortunately I don't have my calculator ready to copy and paste stuff here, so I'm just going to go ahead and graph this in my calculator. So it is x to the third minus x squared. You guys could kind of do this too if you wanted to, minus 49x plus 49. And I'm going to look and see what the graph of this thing looks like. Now, right away I know that just because of looking at this biggest power here, that I know my I'm going to have 3 solutions here because it has a degree of 3. And sure enough, when I graph this thing, I see that it looks something like this. I'll get a different color here so we can enjoy this a little bit more. I think the graph looks something like this. And it'd be nice to know what all these values are. I can go ahead and take a look at my table here, and that might help me find these a little bit better. It looks like one of them is going to be negative 7 and 1 and positive 7. So where it crosses, negative 7, positive 1, positive 7. Those are called the roots, the zeros, the x-intercepts, that type of thing. And so the nice thing is that when I have those roots, and you might remember we did this in class a little bit on the first lesson, that there are corresponding factors that match up with those pretty well. So if negative 7 is a root, that means x plus 7 is a factor. 1 is a root, x minus 1 is a factor. 7, x minus 7 is a factor. And so my binomial factors for this problem will simply be those. And if I multiplied all these together, I won't do that right now, but if I multiplied all those together, sure enough I would get back to this original polynomial. So the idea is factors are fairly easy to generate once you find the roots. The factors are always, I'm going to write this down since it's so important, a factor you can always find by taking x minus a root. Alright, so that's it for today, gang. Thanks for watching, and we'll see you guys in class tomorrow.